So before we get into more area approximation, let's introduce some new notation, and it's called the definite integral. The definite integral ultimately represents the area under the curve. So anytime you see an integral now with a definite value a to b on it, we read this out loud as the definite integral from a to b of f of x. And what that's ultimately asking us to find is this net signed area under the curve. So we can use trapezoids to help us approximate definite integrals. If it's concave down, then it is an underestimate. And if it's concave up, your trapezoid is an overestimate. So now in this example below, they want us to use the table of values of a continuous function above if 4 equal subintervals from 0 to 2 to use trapezoid approximation of the definite integral from 0 to 2. So remember, this just means area under the curve from 0 to 2. So if we have 4 equal subdivisions, that means n equals 4, delta x equals b minus a over n, 2 minus 0 over 4, which is 1/2. And we can see each of these in the table are going by 1/2, so that's perfect. So we need to find the area using trapezoids. So remember, trapezoids area is approximately 1/2 times the base, which is 1/2, times base 1 plus base 2. I misspoke, that was the height. So for our first interval, that is 3 plus 3. And then plus 1/2 times the height times the next two bases, 3 plus 5. Plus 1/2 times 1/2 times the next two bases, 5 plus 8. Plus 1/2 times 1/2 and the last two bases, 8 plus 13. So what I see is area is approximately 1/4 times 3 plus 2 times 3, because these happen twice, plus 2 times 5, because these happen twice, plus 2 times 8, because these happen twice, and then plus 13. So you could actually have jumped straight to this step instead of finding each separate trapezoid. So that becomes 1/4, 3 plus 6 plus 10 plus 16 plus 13, which is 1/4 times 48, which is 12. So the area under the curve using trapezoidal rule is approximately 12 square units.